Make some breast cells turn cancerous? That's a question that prompted Indiana University Medical School researchers to make a new discovery that could significantly impact breast cancer treatment. They identified a gene that they say can make breast cancer cells proliferate indefinitely. Researchers say this gives them a new target for preventing the spread of breast cancer and saving lives. And joining us now is Dr. Hari Nakshatri. He's the professor of breast cancer research at the IU School of Medicine. Thank you, doctor, so much for joining us. Talk about this discovery. The gene, I believe, is called tonsil. It was found in the earliest changes from healthy cells turning to cancerous. Why is that so important?
First of all, thanks for having me. Cancer starts many years before it is clinically detected, and we as researchers have been very good in finding what is wrong with the cancer once it is detected. Our goal is to find what happens at the very early stage, even before it is clinically detected. Can we identify a change that happens? For many years, this has not been possible, but IU is uniquely placed to do this study because we have a bank called Komen Normal Tissue Bank, where 6,000 healthy women donated their breast tissue for research purpose. So we came up with a way to isolate healthy cells from this. And these healthy cells only divide about 10 or 12 times, and then they die off. That's how the normal body cells work. But in cancer, they could lose this capacity to die and keep proliferating. So with our method where we could have the normal cell, comparing them with the cells that are proliferating indefinitely, we identified tonsil as the gene which can confer this indefinite proliferation capacity to the healthy breast cells.
So by identifying this early, what kind of impact will that have on cancer treatment or even prevention if you can identify it early enough?
Yeah, so this particular gene, is what we call amplified in 20% of breast cancer. Typically, there are 2 copies of a gene in every cell of the body. What it happens is in a cancer cells, instead of being 2 copies, it becomes 10 or 20 copies. So if we have a tumor, and if we can identify whether this gene number of copies are 2 or more, then we know this particular cancer is dependent on this gene to proliferate, then we can start targeting that. This is true for about 20% of breast cancers, and we think many other cancers are also dependent on this tonsil gene.
Well, talking about that, I know there are many variations, or I don't know how to really say the right way, but there are many types or variations of breast cancer. Is this tonsil gene pervasive to all of them or in just some of them?
It's about 20% of breast cancers.
20%.
In our studies, we found what we call the estrogen receptor positive breast cancers.
Right.
If they have this gene amplified, those tumors tend to have poor response to treatment. They do worse. So that's the one we are focusing on, what other new drugs we can add to that particular type of cancer.
Okay. Now, where are we right now? At what stage of research is this? When could we actually see this discovery put into practice with patients?
So first, we have already come up with an assay where we can identify which tumor has this gene amplification. So that is already done. The second, we have identified a drug which is already in clinical trial for pediatric cancers. So if we can catch hold of the drug in our lab setting, this drug works only on breast cancers that have this tonsil gene amplification. We have done both in the lab as well as in our models in animals. It works perfectly in them. So what we have been trying for 1 year is try to get this drug from the company, which at the moment has a limited supply of the drug. So once we have more drug become available, our goal is to take into the clinic.
Okay, that sounds very exciting, and I hope that that comes very soon. I want to also tell you that, your research was carried out with specimens from the Komen Tissue Bank. You mentioned that. Many women in the Evansville area have donated to that bank. It was a big push during one of our Komen walks here in the tri-state area, so it's kind of exciting to think that perhaps one of them may have impacted your research, important research. So.
Yes.
All right, thank you, Dr. Hari Nakshatri. Thank you so much for what you are doing there. Keep up the good work. We can't wait to hear more about this. Thank you so much for joining us today as well.
Thank you for having me. Bye bye.
Bye.